Okay.
Right.
So I'd like to introduce our speaker today, Tom Wickham-Jones, and he's going to talk about computing in the cloud, or more specifically, how to use Mathematica in the cloud. So please put your hands together, and I hope you'll enjoy the talk.
Thank you. Right. Okay. Well, we're a select band here. So yes, I mean we can tune this more or less, since you may know more or less about Mathematica. So you've seen presentations that you know something about Mathematica.
Yeah.
But have you used Mathematica at all? Or?
No, never.
Right. Right.
Wolfram, yes, the website and so on, but never Mathematica.
Right. So you've used like Wolfram Alpha, have you? Or
yes, I think so.
right.
Yes.
Right. Okay. So Mathematica is the sort of technology behind Wolfram Alpha,
Okay.
and it's the original technology. So I'll sort of tune things, and if you've got any specific questions, and I'll skip over this since you've seen this before. But if we can go faster or slower,
Yes.
Sure.
depending. So Wolfram Research, we've been making Mathematica since we shipped Mathematica 1 in 1988, and we've been sort of working away on this time. And I've worked on Mathematica since 1990, so not the very beginning, but nearly at the beginning. And I work on development of the core engine. So Mathematica, it's to be an integrated system that combines all sorts of different technologies. Fairly focused. Originally, it was very much focused on math-type computations.
Mm-hmm.
So all the areas of mathematics that are capable of automation. And then in the past years, we've been sort of extending out to sort of, a bunch of other areas. So one of the key things that we like is that we support this notion, we call these computable documents. And, they're documents, an entire document that contains sort of everything. So it's like, it contains code, it can contain data, it can contain documentation. So like the code can be very literate, very literate type programming. And so it can make a totally standalone document that contains everything. So you don't need to load extra files or something. Everything's in one document. There's Is that another? What is that?
I think you've got.
Oh right,
I'm
okay.
so sorry.
Right, yeah. Sorry, that might. So that's the idea, and the idea is that these documents are sort of platform independent. And here's kind of like an example one that I put together. So I've slightly trying to rescale this. So this is one that my son, who's doing a math degree, was working with this one here. And this is a sort of an example of from a sort of math, math area. And it's got, here's some code, here's some sort of definitions, math notation. Everything's all in one sort of document. There's a reference to an external bit of code. But it's kind of a handy thing to have this one document. And as I go to talk about our cloud, technology, this works even. This is a very appealing thing in the cloud. But we'll get to that. So So one simple way of using is kind of as a sort of scratch pad type of thing. You can type in questions. It's right. So 2 + 2 is 4. Okay, that's not so sort of exciting. We can compute things like square roots or sort of algebra types of things. Now one of the things is we have a nice, we have this, all sorts of different sub-languages for things like graphics and modelling. So this is a sort of, a sort of graphical sphere. And one of the things, the sort of features of Mathematica is that, everything can be sort of nested inside everything else. So here I can do some sort of algebra, solve a quadratic equation.
Mm-hmm.
But one of the coefficients is a graphic, you see. So, and it works just like all the other graphics. So,
Mm-hmm.
but it's just nested inside. Now this is not, in this particular case, it's not really practically useful,
Mm-hmm.
but it's just a way that shows that everything can be sort of fed into something else. Sometimes this is useful because you can use it for making up new notations or specialized types of, new sorts of things. Right. So, another part of the sort of proposition of Mathematica is to sort of try to automate things, and one of the ways that we do this is in this creating custom user interfaces. So we have here's a plot command. So it's like very literate. You want to plot something, so you say plot, and then this spits out a user interface for the plot. Now this is an example, I think, where writing a little bit of code. Come in. Do you want to come in? Or don't come in. Right. Writing a little bit of code. I mean, alternative ways of building a user interface like this with a slider. You might script this up in Java or, .NET. And these are very respectable systems, and I work in those. But if you want to make something simple, then, there's some sort of overhead. You have to launch a GUI builder, you've got to pull things around, you've got to wire up callback functions. Now, if you're building some sort of iOS app or something, then you probably need all of that. But if you're just doing a simple thing, it's quite useful to have such a simple way of doing this. And what this does is this sort of empowers people who are not expert programmers, who are able to build non-trivial user interfaces in this way. And I think that's kind of a useful feature. So we have some design principles. So we try to distinguish, we have functions that distinguish between specifying a problem and then describing how to solve it. Mm-hmm. So describing how to solve it is a particular algorithm, but we try to be more abstract, higher level than that. Mm-hmm. We try to provide, automation things, and we try to make everything work with everything else. Mm-hmm. And again, we have this sort of symbolic language, and we try to use that. So here's just some, I'm not going to give a demo of all of these things. Every version we add more functionality, so the version we're just releasing now has like finite element. Actually, there might be some finance uses of finite elements, I suspect. Yeah. Certainly obviously finite element